We are live. Welcome to the green screen room. So this means you can fill this picture in later with wherever you want to put me. And I'll be keeping an eye on the chat here in a little bit, but since it's only a 10-minute, 15-minute lightning talk, I'm going to be going a little bit quick, and then I'll follow up with the chat later on afterwards. So secure supply chains, I think we heard a little bit from Justin today talking about why this is important. I'm going to skip past a little bit about me later on. If you want to check it out, I'll be doing a workshop and we can talk about this if you're really interested. But I wanted to talk about what are supply chain attacks first. And the popular ones out there, we had like the dependency confusion attacks that hit us within the past year or so. That was when you had people that were looking at repositories that companies were using internally and found a way that they could make the same repository name publicly, and then those internal builds of those projects were going out and pulling public things that those researchers were just throwing out there to see if they even worked. So that was hitting a lot of repositories, not specific to containers, but specific to things like, I believe it was Python Node that we're seeing a bunch of the issues with that one. The other really big one that hit the news was SolarWinds. And so we saw that the attackers were going after the build infrastructure of SolarWinds. They got them to sign their malicious application that got distributed out to all the clients, and then that was able to be run on all the different client machines. So a lot of this in the news, it hit the White House. They put out an executive order saying we got to start improving this. So all of a sudden, all the companies that like government funding start jumping on top of this. So you start to see a whole lot of the different businesses out there going after this. And none of this is really new. We saw Ken Thompson way back in 1984 put out a paper that was saying, how do we know we can even trust the compiler? Because the compiler most of us ever use comes from a compiled binary that's already been built, and then it's recompiling itself. So couldn't it just recompile some malicious code right back into itself when it sees it's compiling a compiler, and then do whatever kinds of havoc that you would never know that happened? So attackers have a whole variety of methods to do this. I'm not going to jump through all of these. You can read them if you want to, but the ones we want to talk about right now are the supply chain attacks. And the physical example of that I can think of is the Colonial Pipeline attack we saw. So not talking specifically about software, but if you wanted to go out and attack the transportation network and all the vehicles, you could try to attack each individual vehicle separately. You could go after all the gas stations. Both of those sound like a lot of work. You could potentially go after that pipeline, but theoretically, that's been pretty hardened and secure. They don't let you get too close to those things. And so instead, what they looked for was a nice, easy target upstream. They just found a VPN interface with a reused password to the billing system. They take out the billing system. The company can't charge, send out invoices and collect money. So they shut down the pipeline themselves so that they don't lose money. So they find that soft upstream target before this stuff ever hits production, and they attack that instead. And so that's a physical example of what we're seeing in the software space. In the software space, what you tend to see is instead of compromising the production servers that have been hardened, firewalled off, well secured directly, they go after something upstream. They look at your build servers. They look at some of the upstream dependencies you're using. And as XKC has told us, there's always one of these upstream dependencies that is just one lone developer out there keeping track of, and who knows what happens if he's not paying attention or someone else comes in and takes over the project later on. So what does it take to secure the supply chain? We need to validate our inputs. We need to harden that build infrastructure. So in terms of our CI environment, we need to harden that the way we would harden production infrastructure. Make sure that those images we're building are secure. Make sure the operating systems are secure. We need to actually verify the build process itself. How do you know that you actually did what you were saying you were going to do? We need to make that a much more secure environment. And we need to sign that result. And so as Justin was talking about earlier, there's a lot of work happening in this space of signing the resulting image that we create, any other artifacts we generate. We need to sign all those and then distribute our artifact and the signature, and then verify it at that emission controller level to know that we actually built this thing we know is built by a trusted entity before we kick this off and run it in our production environment. So most of this talk, what I want to jump into is kind of the state of the tooling, because there's a lot of development happening out there, and I want to get into where some of this development is happening, what's going on in that space, and more importantly, where you might be able to want to come in and help out and maybe drive some of that development to help out your sort of environment, what you're trying to solve. So the two software bill of materials standards, SPDX and CycloneDX, in case you haven't heard of a bill of materials, think of it like the ingredients list, but for your applications. And so SPDX focused originally on the licensing, so making sure that you didn't have unknown GPL code in there if you wanted to have everything Apache. CycloneDX was from OWASP, so they focused on the security standpoint of this, making sure there weren't any known vulnerabilities in your code. And each of these have been kind of adopting features of the other one, but they each started off in their own space, made those things required, and then started adding optional features from the other side. So it'll be interesting to see where this plays out. There is a lot of development in there because not only do you want to have the bill of materials for the application you're building, but all your dependencies, you want to have it for your build environment. You want to have a bill of materials if you're running like a SaaS environment for your production environment too. And not only do you want to generate that bill of materials, but you need to have some tooling to distribute it and also to use it and verify it and check it later on when you're in, downstream, something you don't want to generate for no reason at all. So a lot of this is still in work, coming, under development. And so keep an eye on this space and see if there's somewhere in there you might want to check out. Next area I want to cover is attestation. And attestation is, verifying the truth and authenticity of what was happening. And so a couple of the projects in here I'll hit on. In Toto itself is verifying every step you run. You generate a signed little piece of data that says, this is what I did. These are my inputs. This was my output and the command that I ran to do that. And then at the end of your build, you can go through and collect all of those and verify all the steps happened the way you thought they happened, and that nothing came in and interjected something in the middle of one of those steps. It's caching, digesting everything. So if those digests ever don't match from one output to the next input, something went wrong. And the Spiffy Spire project that I want to point out here is looking at how can we trust the actual workloads we're running and the nodes that they're running on. And so this gives you some short-term signing keys that can verify between those two what's going on. Can you really trust the workloads that you're running this stuff, and that people aren't throwing random machines out there that claim to be with who they're really not. In the signing space, we covered a little bit on the Notary v2. They are looking at how they can really revamp that, because historically Notary version 1, it was trust on first use. There was some user experience around if you ever turn it turned on for everything and it started blocking everything, and then you started pulling that one image that wasn't signed, you turn it off and you never turn it back on again. If you're trust on first use and you're ever in an ephemeral environment, like a lot of us try to recommend to be in, that means you trust on every use. That's not good either. So we're looking at ways of how this can be improved with Notary v2, in addition to shipping that signed artifact with the image. So we're pushing that up to a registry and we're trying to ship it as we ship the images around. A couple other projects in this space keep eye on, both Cosign and Recore coming out of the SigStore project. I think that's under the Linux Foundation, but it was originally set up by Google. And so it'll be interesting to see where those go and how they play out. Recore is doing transparency logs. Cosign is doing some of the signing similar to what Notary v2 is doing. And so it's just another competing project in the same space. And the last key area over here that I want to talk about in tooling is distribution and admission control. OCI right now is getting a little bit of a rejuvenation on their development effort. Originally, they were capturing things that were already done, and so they were just documenting and getting the standards put together for that. So the image spec and the distribution spec, they were just capturing those and saying, okay, this is what everybody's already doing. Let's document that and get this written down. And now they're getting into a space of saying, okay, we need to do some new things. People want to have new functionality. They want to start pushing these artifacts into registries. They want to keep track of, maybe we want to push the signature next to the image, but we don't want to have a separate tag for that because perhaps we don't want to clutter our repository up with all these different names. So they're looking for how they can keep those things attached to each other, how you can query the registry to find out where are the signatures for this stuff. So they're getting into some new development space. So it's interesting to see what's happening over there on the OCI area. And a few projects to point out. The one that I'll point out here on this slide is going to be the CNCF security tag, and more specifically the supply chain working group. If you're interested in this stuff, right now they are taking the learnings they had from a white paper on what the best practices are and trying to capture that and build a reference architecture. And so they're taking all the different steps that we're talking about here today, capturing all of that and putting it down into one of these documents. So they're going through a lot of effort there, and it'll be interesting to see what comes out of that. Hopefully we'll have something everybody can use. And so a lot of what we're talking about here today comes from what's going on in that group. Last area I want to cover is reproducible builds. And typically when you have a normal build, we're trying to harden the supply chain, make sure nobody can come in and maybe break one of these nodes that we're running on or detect any of those attacks if they happen. Reproducible builds kind of flips that and says, instead of trying to harden this thing and make it super secure, just run it again. And that's easier said than done, because you run it again and suddenly you get things like timestamps getting injected into your image, externalities. If you ever do like an apt-get update or a pull from a latest tag or something like that, those things might pull a different version the next time you run it from the first time you run it. Maybe you have some host dependencies if it's looking at the compiler version or a library version, something like that. You get something different in your linked libraries or linked binaries you're creating. So this is a challenging project. And the nice thing, though, if you can get it to work, is that any attacker that has to come in, instead of attacking just one node, they have to attack every place you do your reproducible build. And especially if you're looking at the open source space, that means everybody in the open source community that might try to verify one of these images, they can detect if something ever goes wrong with that build. So that's what we're trying to get to make this stuff visible if anything ever happens. In that space, reproduciblebuilds.org, great website that goes through a lot of the challenges and what the process is to try to mitigate that and work around it. And a handful of projects that I'll point out there of who are really focusing on this effort. So hopefully that'll give some people a little bit of direction of what they can look at. And I'm also trying to see what we can do, because a lot of this stuff for the Docker images doesn't use a Docker file anymore. And so I'd like to see if we can get this working in a way that does use a Docker file and try to make the reproducible builds work that way. So in summary, I want to wrap up a little bit and just say, this was not an exhaustive list. I went through, and this is a bit of a speed run through a whole bunch of tools, but the real message I want to communicate here is that this is a complex process. There are a lot of tools they need to integrate. And so there's not going to be any single winner. There's going to be a lot of winners out of this. There's going to be a lot of tools that need to get developed. There's a lot of stuff that's still being written. And so if you're interested in this space, come check it out, find out where the gaps are that you can help out fill, and come join us. It's definitely a help wanted space here. So with that, they gave me a lightning talk. They told me 10 minutes, so I tried to keep this 10 minutes, even though I see on the schedule and they gave me 15. If you have any questions for it, I'll be checking out the chat window on the live stream here. Otherwise, you're free to hit me up on Twitter if you're watching recording afterwards. And this whole presentation, including all the links to the different projects that I was highlighting there, it's all up on my GitHub repo under the sudo bmitch/presentations, and that QR code is going to take you over there. So feel free to check that out and drop any questions you have for me in the chat later on. I'll check that out for you. All right. Thanks so much, everyone. And Michael, I think I gave you a whole extra minute to play your recording. So
thanks.
Good seeing you.
Thanks. I'm just jumping in to say thanks so much. This was great. Really enjoyed it.
Thank you.
All right. Great.
All right. Take care.
Cool. Bye-bye.